Guys, so good evening. We're starting the next part. So we discussed the potential energy and the kinetic energy, right? So today we have to discuss about the elastic potential energy, which comes under the potential energy, right? So we'll discuss start in a second. Now I have to tell you a bit about the I have to tell you a bit about the plan on the August for the 2025 people especially. Now from from the next month we will be doing more of the questions, right? So I'm planning to do more of the questions. Depending on the time that we can allocate, I'm trying to give you the maximum. So like now 2 of the papers are already translated, so I gave them for the typing, and I'll have to check for the corrections if there are any corrections. So I'm going to do that within these few days, and trying my maximum to give like 10 full papers, right? Trying my maximum to give like 10 full papers, and we'll have to discuss it as well. Apart from that, I'm planning to give you some more question banks, like not the banks like bank wise, like the like not the classified ones, but the questions like 50 MCQs wise paper. Like I have like a collection of those question papers, like 50 MCQ wise. There are a few, and like a mixture of MCQ questions and like structured essays. I'm going to separate them. So there will be like MCQs separately, structured essays separately, and essays separately. Like large number of questions will be there. So I'll have to find enough time to answer them. And I'm trying my maximum to do the the discussions as well for those questions, right? So for the coming few months, මේ coming few months ටික තමයි ඇත්තටම ඔයාගේ result එක ඇත්තටම තියෙන්නේ, right? So තාම තියෙන ඒ කියන්නේ තාම ඇත්තටම result එක මෙච්චරයි කියලා කියන්න බෑ. එහෙම කියන්න බෑ. හරි. මේ මාස 3ක් තියෙනවනේ. මාස 3ක් කියන්නේ කෙලින්ම කන පිට ගහන්න පුළුවන්. ඒක තමයි ඇත්ත කතාව. මාස 3කින් කන පිට ගහන්න පුළුවන්. ඒකේ එකම තියෙන්නේ ඔයාගේ ඩෙඩිකේෂන් එක ඔයා කොච්චර වැඩ කරනවද කියන එක තමයි. ඔයා සැරට බහැලා වැඩ කරනවා නම් නේ 25 ලියමුද? හරි සැරට වැඩ කරනවා නම් බහැලා අනිවාර්යෙන් රිසල්ට් එකක් දාන එක පුළුවන්. හරි. ඒක ඔයාගේ ඩෙඩිකේෂන් එකම තමයි තනිකරම තියෙන්නේ. බහැලා වැඩ කරනවා නම් මේ මාස 3 ඉතාමත් ප්‍රමාණවත් ඒකක් දාන්න. හරි. ඇත්ත කතාව. හැබැයි ඔයාට තියෙන මේ ටයිම් එක රිලටිව් ටයිම් එක ගොඩක් අඩුයි. හරි. හැබැයි මේ ටයිම් එක වලට වැඩි කරගන්න පුළුවන් ඔයා අනිත් අයට වඩා වැඩ කරොත්. ඒ ටයිම් එක ඇතුලේ. ඒතකොට දවසකට වැඩ කරන පැය ගාන සෑහෙන වැඩි කරගන්න වෙනවා. සෑහෙන වැඩ කරගන්න ඕන නැකුවම පැය 12 15 සමහරව 18 දක්වා යනවා. හරි. දවසට. එච්චර යනවා. සමහරව මේ වැඩ කරනවා. දවසට පැය 18 වැඩ කරන අය ඉන්නවා. අපි අතර නෙමෙයි. හරි. එහෙමයි ඉන්නවා. හරි. දවසට පැය 14ක් 15ක් 18ක් වැඩ කරනවා කියලා කියන්නේ මේක කරගන්න බැරි නේ. හරි. ගේමක් නැතුව කරගන්න පුළුවන්. සිද්ධිය තියෙන ඉතින් ඒකට ඔයා මේ කැමති වෙන්න ඕන සහ ඔයාට අවශ්‍යතාවයක් තියෙනවා. ඒක තියෙනකොට you will start working and the results will be so නේ. ඒ විදිහට තමයි හැදෙන්නේ. අනිත් එක තමයි මේ ටිකේදී subject balance කරන්න. හරිද? subject balance කරන්න. subject balance කරේ නැතුනොත් වෙන්නේ දැන් මම pressure කරන්නේ නැහැ ඔයගලන්ට මගේ subject එකට විතරක් ඒකක් ගන්න. හරිද? එහෙම කරාන් පස්සේ මට හොඳයි. මට වෙන්නේ දැන් අම්මට අනිත් ඒවා නෑ ඉන්නවා වගේ දිනවා ඒකක් කියලා වෙන්නේ නැහැ. So I'm not doing that. Now your rank depends on all the 3 subjects. Right? Your rank depends on all the 3 subjects, so you have to balance the subject. Otherwise what will happen is you'll get a good mark for one subject and your rank and the set will be somewhere dotේ තමයි. එතකොට the university that you are getting selected, or either you are getting selected for a university will be determined by the three of the, like it will depend on the three of the subjects that you are facing, right? So balance them. We have still time to balance them. Have a good management. That's the thing. For the 3 months you have to have a good management. හැබැයි ඒකත් අර මේ මෝඩ විදිහට manage කරන්න එපා. I think I have told you to how to manage, you know, when it comes to the grades. Now if you have a S grade in something and if you have a B grade in something, what should you give the first priority to? To the B grade or the S grade? Now you should give the first priority to the B grade, right? Now that's the thing, I'll teach you that. Now listen, right? So it's a time game, right? You have to think about the time that is left, right? So if you have a B grade for one subject and a S grade for one subject, right? You have 3 subjects now. Let's say a C grade for the another subject, right? So let's say you have a B grade for one subject, C for one subject and S for one subject. So when you are studying, what should you prioritize first? You should prioritize the B subject because you have studied enough, you have practiced enough. It will only take maybe a few days to get this into A, right? So that time you should give the first. Otherwise you are losing this B, right? Never do that. If you have a B in one subject, never leave it to like gain the marks from a lower subject before you're taking this to A level. You know, so try like give them best priority to this B grade and make it to A within a minimum period possible, right? Within a minimum period possible, because when you give this subject to A level, that means you are only having like very small mistakes. That is all there. You already know the theories. Now even if you have a C mark, a level of a C grade in any of the subjects, that means you have gone through the whole syllabus. You know the theories, right? You know the theories. You have studied something, not something. You have so far studied and you have so far understood the whole syllabus, right? The majority of the syllabus, or else you have understood it. Only you have understood it and you know it, but you haven't practiced it and you haven't answered the questions and the papers. So you are ending up with a C because you haven't practiced it, right? So if you practiced it enough, like do more questions, answered more of the papers, and do the timing work as well, like do the questions with the timing, like do 50 MCQs with a 2 hour period of time, and do it within the time, right? And if you do that way, this C will rise up to a B for sure, right? It will rise up to a B, because when it is a B, that means you have practiced it. You have answered the questions. You have gone through the difficult questions as well. So you already have like earned the potency for this one. And when it comes to A, that means you are minimizing the mistakes. You are making a lot of mistakes, you know. Sometimes when you are like facing that is because you don't have the experience. Maybe a hard question comes and you are like not leaving it until the time finishes. That is lack of experience. You don't do that because you are not facing an exam to prove that you know the harder questions more than the others. You are there to answer the maximum possible and get the maximum the marks possible, right? So that sort of a thing can happen in the exam. That is why you most of the time will remain in the B, right? So when it comes to the exam, you have to have the minimum mistakes possible to gain the maximum marks. You don't have to get 100%. You have to get a 75%. For that, you have to have the experience to minimize the mistakes. That is A, right? So for in that that means if you are in a B, that you have practiced more of the questions, that you have gone through so many of the theories and you have understood it, even you have done difficult questions. Now there's only a very low limit, a gap to get this into A. So do it first. That is first thing. And when you got through it, what you have to do is keep the touch. Check if you have if you like check, like do MCQ, full MCQ and check if you are missing still something, if you are missing any of the theory, if you are missing any of the question, check it. That is the first thing, right? And the other thing is, now after like taking this to A, you go for the C and S, right? So for a C to bring it up to a B, it will take a bit of time, right? Still, now the priority should be given to C, right? And the S subject, now like you have to decide the limit, time limitation. You have this much of a time, you have to decide I will be studying this subject and bringing it up to a B within this certain period of time. And once the certain period of time is finished, you don't have enough time, that means you have to go to this subject to bring it up, otherwise you will fail this. දැන් C එක B එකට දාගන්න time එකක් දාගන්න. ඒ time එකේදී you finish it. Even if you couldn't finish it, nothing to do, you have to come to this one because you can't fail this. නේ. ඉතින් මේකට ඇවිල්ලා ඊට පස්සේ මේ subject එක කොහොම හරි උඩට ගන්න තමයි තියෙන්නේ. ඊට පස්සේ මේ දෙක balance කරගන්න ඒකක් තියෙන subject එකක් මොකක් හරි තියෙනවා නම් ඒක මේ කඩා ගන්න එපා. ඒක අපරාධයි. හරි. අනිත් එක C එක B එකට ගන්න, B එක A එකට ගන්නට වඩා වැඩි time එකක් යනවා. මොකද C කියලා කියන්නේ you know the theories. ඒක සාමාන්‍යයෙන් පේපර් එකේ A margin එක දෙනවා. C margin එක දෙනවා. ඔයාලට ගන්න දෙනවා. chance එක දෙනවා. B එක ගන්න පොඩ්ඩක් අමාරුයි. දෙන්නේ නැහැ ලේසියෙන්. ඒකින්ද ඒකට ප්‍රැක්ටිස් කරන්න ඕන, ගණන් හදන්න ඕන. You have to do that. ඒකට යනකොට ඊටත් වඩා එක්ස්පීරියන්ස් වෙනවා. ටයිමින් කරලා මිස්ටේක්ස් අඩු කරලා ගොන් වැඩ අඩු කරලා නේ. ගානට අවශ්‍ය ටිකම ගානට අරගෙන ලකුණු ටික හදාගෙන ඒකට යන එක ඒක එක්ස්පීරියන්ස් එකත් එක්ක එන එක. එතකොට ඔයා ප්‍රයොරිටයිස් කරන්න ඕන හැමතිස්සෙම B තියෙනවා නම් B එක ඒකට ගන්න. ඊට පස්සේ C එක ඒකට ටයිම් එකක් දෙන්න. ඊට පස්සේ ටයිම් එක ඉතුරු කරගන්න ඕන. ඒ ඉතුරු කරන ටයිම් එක තමයි S එකට දාන්නේ. හරිද? එහෙම නැතුව එකපාරටම සබ්ජෙක්ට් මොනවා හරි A B තියාගෙන S එකක් තියෙන එකට ඔක්කොම අතහැරලා බහින්නේ. දැසොත් මොකද වෙන්නේ? මේ දෙක බහිනවා. දන්නේ නැතුව බහින රාස්ටිකලි බහින්නේ. නිකන් නෙමෙයි. සරාස් ගාලා බහිනවා. හරිද? ආපහු මේ දෙක හදන්න ගියාම ඊට පස්සේ එන කට්ටක් ගන්න වෙනවා. එහෙනම් එහෙම කරන්න එපා. සබ්ජෙක්ට් තුන බැලන්ස් කරන්න පාඩම් කරනකොට. හරිද? සබ්ජෙක්ට් තුනම බැලන්ස් කරන්න. නේ. ඒක මේ ටිකේ කරගන්න පුළුවන්. හරිද? මේ ටිකේ මැක්සිමම් කරගන්න. ඒකින්ද සබ්ජෙක්ට් තුන බැලන්ස් කරගන්න ගන්න පුළුවන් මැක්සිමම් මාක් එක. මැක්සිමම් Z එක ගන්න පුළුවන් විදියට ප්ලෑන් එක හදාගන්න. මොකද ඔයාට වටින්නේ Z එකයි රෑන්ක් එකයි. ග්‍රේඩ් එක නෙමෙයි. හරි. ඔයාට වටින්නේ Z එකයි රෑන්ක් එකයි. ඒක තමයි ඔයාව තීරණය කරන්නේ ඔයා යුනිවර්සිටි එක මොකද්ද කරන ඩිග්‍රී එක නේ කියන එක තීරණය කරන්නේ Z එකයි රෑන්ක් එකයි. ඒ Z එකයි රෑන්ක් එකයි ටාගට් කරලා වැඩ කරන්න. හරිද? ඒක හරියට බැලන්ස් කරලා ලස්සනට කරන්න හොඳ මැච් එකක් ගහන්න. You have the time, right? Right. So that's it about. Okay, shall we come to the lesson now? Right. So අපි ඉස්සරහට ඒ කියන්නේ ජුලයි ඉවරනවත් එක්කම සාමාන්‍යයෙන් ආපහු සමරයිසේෂන් එකක් යන්න ඕන. සමරයිසේෂන් එකක් කරලා දෙන්න මුලින් නම් පාඩම් ටිකේ අවශ්‍ය ටික ඔක්කොම නෙමෙයි. සමරයිසේෂන් එකක් කරමු. ඊට පස්සේ questions discuss කර උඩට ගමු. හරිද? ඕක මහන්සියලා වැඩ කරලා උඩට ගන්න ඕන. මම 10 times වැඩ කරනවා නම් you have to work 100 times. that's all I have to say. right? මම 10 times වැඩ කරනවා නම් 100 times වැඩ ගන්න වෙනවා. එහෙම කරතින් මේකේ බයිනක result එකක් දාන්න පුළුවන්. හරිද? මේක අමාරු එකක් නෙමෙයි. and you are getting additional marks for the English medium. නේ? English medium එකට additional yeah Z එකට additional add වෙනවා. yeah for the English medium points ගානක් add වෙනවා. පොඩි a bit of a points will be added because you are doing English medium and so you have a better chance of getting selected for a university. So take it, right? Do your best. Game again. That's so 3 months you have, and now so many things are there. Mange katawa can just for now. I can't remember if I told this story. Now this is about a student from 2025. You know him. Yeah, I won't tell. But so this guy, he's having a trouble now. How can I say a trouble? it's not a trouble, he's having a disaster now. Yeah, he has like a family problem is there. Now his father is a alcoholic. Or a බීලා ඇවිල්ලා අම්මට ගහනවා. හරිද? ගෙදර rent එකට ඉන්නේ. He doesn't pay the rent. Right? The guy doesn't pay the rent. Even the water bills and the electricity bills have loaded. වතුර කපලා තියෙන්නේ. electricity තියෙන වතුර කපලා තියෙන්නේ. ගෙවල් ගාවකින් ගන්න. Like his mom having a surgery, she can't work. And he has a younger brother. So nothing is left for him other than working. Now he's working for a salary. salary එකට work කරනවා. මොකද එයාට water bills ටික, electricity bills ටික ගෙවන්න තියෙනවා. rent එක ගෙවන්න තියෙනවා ගෙදර මාස 3ක විතර rent එක හිර වෙලා. ඒ ඇස්සේ පාඩම් කරනවා. හරි. So he's working from 8 to 5 in a sales දාන්න යන අයගේ අර බඩු දාන්න යන ඩොරි එකකින්. අන්න එයා විදියට යන්නේ. මම මෙහෙට ගේන්න හැදුවා. මෙහෙට ගේන්න මිනිහා කැමති නෑ. තාත්තා එතන මෙහෙ නතර වෙන්න යනවා. මෙහෙ ආවතින් තාත්තා එහෙ කේසින්ද එහෙ ඉන්න තමයි කියන්නේ මම කර වලියක් ගෙතින්. මිනිහා ඉන්නේ බැබේර මිනිහා තමයි. එතකොට මිනිහට එහෙම වෙන්නත් බෑ. ඒකින්ද අර වැඩේට තමයි යන්නේ. 8-5 යනවා. රැහැට තමයි පාඩම් කරන්නේ. හරිද? මිනිහා එහෙම පාඩම් කරනුන් ඉන්නවා. අන්තිම ක්ලාස් වෙන්න බෑ. ඔන්ලයින් රෙකෝඩින්ග්ස් ටික තමයි ගන්න. දැන් මෙහි ඉන්න සර්ලා තුන්දෙනා විරාජ්ගෙයි කමල් සර්ගෙයි මගේ රෙකෝඩින්ග්ස් ටික තමයි දෙන්නේ. ඉන්නේ ඒ ටිකෙන් තමයි ගෙම ගන්න. හරි. මට කියන්න බෑ කැම්පස් යන්න පුළුවන් ඒ කියලා ඒකොල්ලට. උට තියෙන මෙන්ටලිටි එකයි තියෙන ප්‍රෙෂර් එකයි උට තියෙන ටයිම් එකයි එකේම කරන්න බෑ. හරිද? So you all have an opportunity, right? ඒ වගේ ප්‍රෙෂර් එකක් ඔයගොල්ලන්ට නැහැ. හැබැයි එහෙම එකක් නැහැ කියලා එහෙම එකක් එන්නේ නැහැ කියන්න බෑ. හරි. එහෙම එකක් එන්නේ නැහැ කියන්න බෑ. ලයිෆ් එකේ කොයි වෙලාවක හරි කොයි වගේ දේවල් වෙයිද කියන එක අපිට කියන්න බෑ. සමහර වෙලාවට නේ මොකක් හරි අසනීපයක් වුණා සේසතම් වේදම් කරන්න වෙන්න පුළුවන් ෆැමිලි එකේ. නේ zero වෙලා යන්න පුළුවන් බැංක්‍රෆ්ට් වෙලා යන්න පුළුවන් මොකක් හරි වෙලා. එහෙම මොකක් හරි වුණොත් the only safety you have, even for myself, even my story is like that. Education is the only safety that you have. Education එක තිබ්බොතින් ආට ඉතින් එහාට survive වෙන්න පුළුවන්. ඒක නැති වුණොත් ඔයාට කවුරුත් සමහරට නැති වෙනවා. උදව් කරන්න මිනිස්සෙක්වත් නැති වෙනවා. that is the reality. හරි. ඒකින්ද මේක කොහොම හරි හරියට බහැලා කරලා මේක එහාට පන්න ගන්න ඊට පස්සේ ඔයාට ලොකු සේෆ්ටි එකක් තියෙනවා. දරුවට ඒක නැති වෙන්නේ ඕනම කාලේ. උට ඒක කරගන්න බෑ. දැන් මට කියන්නත් බෑ මොකද. මම මගේ අතේ තියෙන පොඩි ගාණක් හරි දෙනවා. හැබැයි අර ඒ තියෙන මට්ටමේ මට මුනිහව කරට ගන්න බෑ. ඌගේ මෙන්ටලිටි එක මට කරට ගන්නත් බෑ. හැබැයි ඌ සෑහෙන හොඳයි. හරි. සෑහෙන හොඳයි කියන්නේ ඌ ඒක ගත්තා අතට එකක්. වගකීම ගත්තානේ. අනිත් එක මම දන්නේ මිනිහා ඌ hina වෙලා ඉන්නේ. මේ මෙන්ටලිටි එක මාර ග්‍රේට්. මට එහෙම ඉන්න බෑ. හරි. මට ඒ වගේ එක්ස්පීරියන්ස් තියෙනවා. නැත්තේ නෑ. ඔහොම නෑ කියන්නේ. ගහ ගන්නවා වගේ ඒවා එහෙම නෑ. එච්චර දන්නුවොත් නෑ. හරි. එතකොට එහෙම එනුන් ඉන්නවා. හරි. එහෙමලත් ඉගෙන ගන්නුන් ඉන්නවා. ඕගොල්ලන්ට ඒ මුකුත් නෑ. හැබැයි ඒ වගේ පැත්තකට පාර කපා ගන්න එපා. ඔහොම ඉඳලා එහෙම වෙන්න පුළුවන්. එහෙම වෙන්න එපා. එහෙම වෙන්නේ නැති විදියට පාරක් හදා ගන්න ඕන ඉගෙන ගන්න එක. এডুকেෂන් එක තමයි එකම තියෙන දේ. ඒක මටත් එහෙමයි. මම ඒක ඔන්ලයින් එකේ කියන්න කැමති නෑ. මගේ පර්සනල් එක්ස්පීරියන්ස් උත් තියෙනවා. මම ඒක ඔන්ලයින් එකේ කියන්න කැමති නෑ. මම එහෙම අර මම ඒ ටික ප්‍රසිද්ධ කරලා මේ views ගන්න ළමයි වැඩි කරන්න මම ආස නෑ. හැබැයි මගේ ලොකු පර්සනල් එක්ස්පීරියන්ස් එකක් ඒ වගේක් තියෙනවා. තියෙනවා. හරිද? කියන්නේ මම ඉගෙන ගන්නකොටත් මට මගේ එන්වයරන්මන්ට් එක එහෙමයි. ඒ වගේ තමයි. හැබැයි මම ගේම ගැහුවා. ගේම ගැහුවගෙන මම ඉගෙන ගත්තා. ඕගොල්ලන්ට එහෙම නෑ. හරිද? ගොඩක් දුරට එහෙම නෑ. එහෙම තියෙන එකේ මේ උපරිමයේ ප්‍රයෝජන ගන්න සහ එහෙම තියෙනවා නම් ඒත් උපරිමයේ ප්‍රයෝජන ගන්න. මොකද බේරෙන්න තියෙන එකම chance එක තමයි ඉගෙන ගන්න. ඒක හරියට කරගත්තොත් ඔයාලට ලොකු සේෆ්ටි එකක් තියෙනවා. ඒ සේෆ්ටි එක හදාගන්න try කරන්න උපරිමයේ මේ පොඩි කාලේ. හරිද? අඩුම ගානේ මාස 3ක් තියෙනවා. ඔය මාස 3 try කරන්න ඒ උපරිම safety එක ගන්න. Right. Come to this one. Elastic potential energy. Right. Now, listen. So when it comes to the elastic potential energy, now for all the works being done, that means you're putting an effort or a force and you're moving an object. So there's a force and a displacement, right? There's a force and a displacement. So let's say I'm putting a force on this object, which is F, and moving it for a d displacement. It moves a d displacement here, right? So the work done here is what? F into d, right? F into d. And did you understand that this F is constant here? The F doesn't change, right? So the F doesn't change and the displacement happens with a constant F. So the work done is this constant F into d, right? Constant F into d is the work done. And let's say you are working on something else. Let's say you have a spin like this one. So now if I draw this in a diagram, it will be something like this, right? If I draw this in a diagram, it will be something like this. Now this is the displacement, this is the force applied. Bro, no poles allowed. Hi, this is the force, this is the displacement. So we discussed that the force is constant, but the displacement moves on, right? So the force is constant, that means the value doesn't go up or down, it's constant. Somewhere here, let's say it's somewhere here, but the displacement increases, right? It goes on. So the work done will be something like this. The force is constant, doesn't change, but the displacement increases. මේ force එකෙන් මෙයා දිගටම displace වෙයි යනවා. So the work done here is what? The area of the graph, isn't it? FD, right? Always the work done is FD. When it's F and D in y and x axes, the work done is F and D, right? And if it comes to this, something like this, yeah, I'll take this one. If it comes to spring like this, right? It's a spring. So you're applying a force. A force is applied, and you are increasing a certain length. Let's say the extended length is E. Now the extended length is E, or you can take it as D as well if you want. Now the extended length is E, or the displacement now here is E, right? The force applied is F. So what is the work done here? Is it Fe, or less than it, or more than it? The work done here, is it Fe or less than Fe or more than Fe? Less than Fe. Why is that? අදින්න අදින්න ලේසි වෙනවද ඔපොසිට් එකද වෙන්නේ? අදින්න අදින්න අමාරු වෙනවා නේ. අදින්න අදින්න අමාරු වෙනවා. ඒ කියන්නේ ඔයා මෙතන ඉඳන් පොඩි ලෙන්ත් එකක් අදින්න F force එකක් දැම්මා නම් ඉතුරු ටික අදින්න F එකෙන් පුළුවන්ද? බෑ. You have to increase the force. අමාරු වෙනවා. එන්න අමාරු වෙනවා. ඊට පස්සේ එතනින් පල්ලෙහාට අදින්න you have to put more effort. So the force is increasing. Now that's the difference. Now the force here is, now it's not constant. Do you understand that? In a spring or in any sort of like a stretchable thing, when you're applying a force, you have to increase the force to get more displacement. Get it? So the force is increasing. It's not constant like this one, right? So the force is increasing. So if I put it in a graph like this, right? If I put it in a graph like this, something like this, this is the displacement or the E, this is the force. Now the force isn't constant, force is rising from the zero and it's increasing, right? The force is rising from the zero and it's increasing, right? So it's something like this, it's increasing, right? Now the force is increasing, yes. So Now the work done here should be the area of the graph. Now what is the area of this graph? Half, yes, because this is a triangle, half into base into height. So half df or half fd, or if I take it in extension E, it will be half fv. In another way, now tell me the force is, it's 0 to F increasing. Can I take the force F as the complete force? No, right? You can't take the force F as the complete force, can you? You can't, because it's increasing. So what would you take in a moment like that? You have a force increasing from 0 to F. You can't take the final force. You have to take the median. So what is the median? The initial plus final divided by 2, right? So even if you take it from the triangle, now if I take this one as, doesn't erase like that. So if I take it like if this is E, so if I take the area will be half Fe, isn't it? It will be half Fe. And even if I consider the median force, it will be 0 plus F over 2. Now this is the actual force acting, right? Not the final force, not the initial force, but the median, 0 plus F over 2. The median force into extension or the displacement will be the work done, isn't it? So again the equation will be F over 2 into E, which is half Fe again, isn't it? Hey, මේක එතකොට add කරාම පස්සේ මොකක්ද දෙන්නේ? 0 plus F කියන්නේ F නේ. F over 2 E වලින් multiply කරාම E. So මේ half එක එළියට ගන්න පුළුවන්. Will same, right? So it gives the same, or the potential energy, elastic potential energy will be half Fe. Get it? Right. Now come to the theory note. Right. Elastic potential energy is the energy stored in an object due to the elasticity, the property of stretching. This depends on the spring constant and the displacement of the elastic object. Now the spring constant you might not know for now, right? Spring constant is something constant for the spring that takes, right? We take it as the K value. I'll tell you about it. But like take from the force and the displacement. If you take it from the force and the displacement, it will be half Fe, right? This is the equation we usually use, right? And there's another thing like K, the spring constant that we discussed. Now there's a relationship between the force and the spring constant, right? There's a relationship between the force and the spring constant. It's something like this. The force applied and the extension are directly proportional, isn't it? When the force is increasing, the extension is also increasing, right? So this the relationship or the proportion can be turned into an equation. Now this is a directly proportional relationship, right? So we can turn this into an equation. How? Using a constant. So what is the constant you are putting here? K constant. K is the spring constant, right? So it's F equals Ke, right? It's F equals Ke. This you will be learning under the elasticity, which will be I'll be teaching soon for the 2025. For you people, you have to wait, right? Now F equals Ke, right? Now this equation can be used for the elastic potential energy equation of half Fe. Now you can isolate F. The F is already isolated, so F is Ke. So instead of F, you can apply what? Ke. So Ep equals half. Instead of F, I am applying Ke into E. So that gives what? half ke square. Sometimes they put x for e, right? Sometimes they put x for e, so gives the same formula, EP equals half kx square or half ke square. So the e or x is the extension, right? K is the spring constant and gives the elastic potential energy that is stored, right? Would you want to write it? How the equation because the questions will be on for the exam, that's fine. Right? Right. So half kx square is there, right? Shall we write the constants and the extension of these symbols? Now the k is spring constant, x is extension. Here the F is force and the E is again extension. Right? And you see the x here. When the force is applied, you can extend it. Now this is the length extended, right? X is the length extended. K is the spring constant. F is force. E is back again the extension. Right. Come to the next part. Right. Principle of mechanical energy conservation and the conservation of energy. Right. Now none of the above mentioned energy can be created or destroyed. It can only be converted from one form of energy to another, right? So now this is a famous one. Now what does it mean though? What does the law of conservation of energy means? What does it mean? Yes. Yeah. Okay. Now it is mechanical energy. Now even again energy is constant. That is what it means. Like let's say this is the universe, right? Now this is the universe, right? So universe has a constant energy. That is what it means actually, right? Energy cannot be produced or destroyed. It only converts from one energy form to another. So if let's say this is the universe, now this have this has like 100 joules of energy, and this is constant, which means it doesn't increase or decrease, can't be produced or can't be destroyed. So can't be produced means this never becomes 101 joule, and can't be destroyed means this never can become 99. Get it? So it can't be produced, never becomes 101, can't be destroyed, never becomes 99. It only stays 100 joules forever, but the energy inside is always converting from one form to another, right? It always converts from one type of a form to another, right? The energy is there in like many of the ways. It's always converting from one to another, right? Let's say the kinetic energy 100 with the complete the ඒකින්ද තමයි අපි energy waste වෙනවා. waste එකක් තියෙනවා හැමතිස්සෙම. එහෙම ගන්න පුළුවන් වෙච්චද ඒ කියන්නේ අපිට 100% conversion එකක් ගන්න පුළුවන් වුණොත් ඒ waste වෙන්නේ ඇයි? resistance එක. ගොඩක් කාල resistance එකකින් තමයි waste වෙන්නේ. ඔව්. ඒ කියන්නේ මොකක් හරි රෙසිස්ටන්ස් එකක් තියෙනකොට අපිට රෙසිස්ටන්ස් එකට against work කරන්න වෙනවා. ඒ එනර්ජි එක waste වෙනවා. හැබැයි අපිට කවදා හරි මොනවා හරි systems හදන්න පුළුවන් වුණොත් zero resistance. අන්න එතකොට ඒකේ efficiency එක 100%. efficiency will be 100% නේ. කියන්නේ input එකයි output එකයි same. But in most of the cases, input and output aren't equal because the energy is getting waste, right? So, එතකොට මේකේ principle of mechanical energy conservation එකේදී කියන්නේ මේක තමයි මේ ගොඩාක්ම පාවිච්චි වෙන එක. ඒ කියන්නේ mechanical energy එක conserved. That means the kinetic energy is always converting into potential energy and the potential energy is always converting into kinetic energy, right? ඕකේ අපි calculations කරනවා. kinetic energy එක potential energy වෙනවා, potential energy එක kinetic energy වෙනවා. ඕකේ අපි වැඩිපුර යන්නේ මෙන්න මේක. ඉතින් ඒකෙන් කියන්නේ මොකද්ද? මෙන්න මේ potential and kinetic energy එක අපි constant එකක් විදිහට සලකනවා. ඒ කියන්නේ අපි මොකක් හරි object එකක් VC කරොත් උඩට මෙතෙන්දී VC කරනකොට මම මෙතෙන්දී ගන්නවා potential energy 0 කියලා. VC කරනකොට maximum velocity එකකින් යන්නේ. That means the highest උඩට යන්න අඩු වෙනවා. The highest velocity means the highest kinetic energy and the lowest potential energy. But when it goes up, what happens? The kinetic energy reduces or is getting wasted, and the kinetic energy decaying is transferred into potential energy because the height is increasing, right? So when it goes to the top, where it stops, when the object stops, that means the kinetic energy and the velocity are 0 and the height and the potential energy is maximum, isn't it? So that's what happens. The highest kinetic energy in the ground will be the highest potential energy in the top, right? So at the top the kinetic energy is 0, at the bottom the potential energy is 0. So all the kinetic energy has converted into potential energy. So what happens in the middle then? The half of the kinetic energy මොනවාද? එයාවල අපි එයා resistance එක 0 කියලා තමයි ගන්න, negligible කියලා තමයි ගන්න. We don't count it, right? So what happens in the middle? Like when you are throwing something, what happens in the middle? දෙකම තියෙනවා. So half of the kinetic energy is also there, half of the potential energy is also there, නේ. So අපි equations දානකොට ඔන්න ඔය දේවල් consider කරන්න වෙනවා. අපි questions කරනකොට ඒව චුට්ටක් බලමු. හරිද? ඒ දාන විදිය ගැන එහෙම consider කරන්න වෙනවා. ඕකේ essay කැලි එහෙම ඇති. ඒ වගේ ඔය දානකොට ඒක consider කරන්න වෙනවා. ඊට පස්සේ I'll be giving more questions. ඒ වගේ දිහෙන් බලන්න කොහොමද හරියටම equations apply කරන්න කියලා. Right. Now these two parts we discussed, did we? Yeah. Did we do this? I think we did this. Right. So did you do this one as well? No. Try from this one. Third question. Yes. කාලට මේක හම්බුණාද? question bank one එක. මේක හම්බුනේ. ඉතින් ඔගේ question bank එකේ තියෙන ඕක ආපහු මේ එක හම්බුනේත් නැද්ද මොනවාද මේ PPC 1 2 දෙකම question bank එකක්වත් හම්බුනේ force එක වෙනයි question bank වෙනයි question bank වල ඔන්න ඔය කව එක තියෙනවා ඕකේ එකක්වත් හම්බුනේ නැද්ද ඕකේ තුනක් ඇති ඕකේ දෙක ඇති තව පල්ලෙහා වංගව යම් දීලා ගන්න අපි 2/2 යන් හොඳේ 2 minutes වගේ ගන්න question එකට අපි ඊට පස්සේ discuss කරමු See that? ඒත් හරි. අතන පිටිපස්සට තමයි යන්නේ. අතන. පුතේ. අය අතර. වලක්. චමත් ෆුල් පේපර් ගෙවුවේ? පාස් පේපර්. ගාලා බලන්න දැන් යනකොට ගහන්න මොන. ඉසු ගෙවුවා? නෑ, 51 ගෙවුවේ නෑ. කීයද තිබ්බේ? 51 ගෙවිත් නැද්ද? චමත් 51 ගෙවිත් නැද්ද? කීයද? 29 මොන අවුරුද්දද? 2015 හරි. 31 කියන්නේ C වගේ දෙයක්. හරිද? What is the answer? first question එක හදන්න ඊට පස්සේ අපි 2 minutes by 2 minutes වලින් මම time එකක් දාන්න. ඒක ඉවරයිද? කීයද ආවේ? yes. හරිද? යෝහන් ඈ? හතරත් ඇදුවද? ඔව් හතරට එක තමයි. Done? So what happens in the third question? When you throw it, the maximum velocity here becomes the maximum potential energy at the top. So those two energies are equal. That is the law of conservation of energy. Isn't it? This energy has transferred completely into potential energy at the top. So half mv square should be equal to mgh, right? So that is the equation there. Why do we put it? The conservation of energy. Done? What's the issue?
highest maximum height එකට ගියාම එතන 80 ms minus
Even the equation is correct. Half m square equals mgh. So apply the values. What happens to m? Now the velocity is given.
Yeah, okay.
So m to m what happens? It's the same mass, right? Cancels out.
Okay.
So what's left? Velocity and gravitational acceleration and height. So you know the gravitational acceleration, right?
Okay.
So you were like teaching myself, right? Got the answer? How much is that? 320 years. So how do you simplify it? How you apply it? Yes. Half mv square is equal to mg h. So what happens? M to m cancels out. Now the half v is 80 square, right? Equals g is 10. You have to find the h. Now 80 square is 8 square is 64. The 10 now this is 8 into 10. No? So 8 square is 64. 10 square is 100. So that is half 64 and 2 of the zeros, isn't it? 64, 2 of the zeros equals 10h. Now one of the zeros can be cancelled out. So h equals 640 divided by 2, which is 320 meters. Right? 320 meters. Got it? You have to apply it and see what happens. Right? Or you have to like trying like the way of doing something is you try doing it and you'll find eventually a way. Can someone increase it? Where's the remote? उतरना है? हाँ, AC remote है? AC remote है?
අඩුවරනද?
වැඩි කරන්න යාර සීතලයි. Right? Then do the next question. The maximum height to which an object project. That's what we discussed. Fourth question. If the above object falls down a precipice 80 meters deep while falling back, the velocity of the object at the bottom of the precipice will be. Now that means now the object that you throw up comes down and it goes further in a precipice, which means a pit. මොකක් හරි වලක් ඇතුළට යනවා. Right? එතකොට වල ඇතුලේ final velocity එක තමයි they are asking. Now it's something like this. Now this is the object you are throwing and it goes up and goes somewhere here and comes down to the same ground level and it goes down in a pit. So sort of a pit like this. It goes down in a pit. Now they are asking the velocity at the bottom of the pit. The height of the pit is given 80 meters. This is 80 meters. I had to find the velocity at this point. Mettana velocity. Now this height we already found through 320. Kilometers, meters karna, you have to multiply it by 1000. 2 hours to make it second, you have to multiply by 3600. කියදෙන්න. just 40 coba dapat itu වැටෙන්න උතරින් ගන්න නෙමෙයි වැටෙන්න උතරින් 320 වලින්
80 අඩු අතන ස්ටාර්ට් එක බිඳුව
නෑ ස්ටාර්ට් එක බිඳුවක් ගත්තොත් මෙයා වැටෙන්නේ 400 meters.
ඒ කලින් දෙන එනර්ජි එකමයි එතනදී
ඔව් හැබැයි යා දැන් තියෙන height එක කන්සිඩර් කරොත් කලින්ට වඩා වැඩි 400 වෙලා තියෙන්නේ මෙතන 0 කියලා ගත්තොත්. මෙතන 0 කියලා ගත්තොත් මෙතන තියෙන potential energy එක plus මේක minus. එතකොට මේක equal වෙනවා half mv square plus minus mgh. The time is up. Did it? Huh? First answer. Shall I do it? So you can do it in two ways, right? You can do it in two ways. Now this is the ground level, right? This is the pit or precipice. The object moves up and comes here. It's 320 meters till there, right? And comes down to the pit. Right, so it comes down to the pit. So it comes down to the pit like this. Now this is 320 meters. This height is 80 meters. Right. So there's two ways of doing it. Either you can take the gravity zero level from here and calculate the values from there, or you can take the gravity zero level from the ground here, right? So if you take the gravity zero level from here, from the ground, right? So the mgh from here to here will be plus, here to here will be minus. So the mgh1, the upper part, should equal to the half mv square here, right? You can මෙතන නම් මෙතනට plus නේ, should equal to half mv square here plus, not plus, minus mgh 2 here, right? That is one way of putting the equation. එතකොට mgh 1 එක equal වෙනවා mgh 1 එක equal වෙනවා මෙතන තියෙන half mv square plus මෙන්න මේ minus mgh 2 එක. නැත්තම් the other way is you take the gravitational zero level, gravity zero level here, potential energy zero level here, right? මෙතන ඉඳන් ගත්තොත් මෙතන තියෙන height එක 0 වල ඉඳන් මෙහෙට තියෙන ඔක්කොම either plus or minus, right? අපි හිතමු මේ පැත්තට තියෙන value එතකොට එක value එකක්. එනතර height එක කීයක් එනවද? 400 එනවා නේ. එහෙනම් කෙලින්ම mgh එක equal වෙනවා half mv squared. මේ දෙකෙන් එකක් දාන්න පුළුවන්. right? කෝක දැම්මත් එකම ඉන්නේ. Now what happens? m to m cancels out. G is 10, first height is 320 equals half, we have to find the v square or the v minus g is 10, H2 is 80. I get 3200 here. That's half V square minus, this is 800, minus 800 comes this way. What happens? Becomes plus, that is 4000. Now half V square equals 4000 and the V square equals 8000, right? Making gathot ehime. Making gathot m to m cancels out, G is 10. Now the height is how much? 400 equals half V square. එතකොට මෙතන 4000. 4000 දෙකෙන් cross multiply වුණාම V square equals 8000. Same, right? Same නේ. දැන් අපිට තියෙන්නේ මෙයාව simplify කරගන්න. V එක ගන්න. So V කියලා කියන්නේ 8000 වල root එක. දැන් අපි මෙයාව surds වලට කඩා ගන්න ඕන. We have to break it into surds. First one. So how do you break this into surds? අපිට 8 එක ගන්න පුළුවන් 4 into 2. 8 එක 4 into 2 කියලා ගන්න පුළුවන් 100 එක තියෙනවා. Yeah. 100 එක වෙනම ගන්න පුළුවන් යාව root එකක් තියෙන ඉඳ ඊට පස්සේ 10 එකක් ඉතුරු වෙනවනේ. 8 එක මම කැඩුවා 4 into 2 කියලා. 100 එක ගත්තා වෙනම ආපහු ඉතුරු වෙනවා 10 එකක්. දැන් මේ ඔක්කොගෙම root එක. 4 එකේ root එකක් තියෙනවනේ. ඒක 2. 2 වලට root එකක් නැහැ. ආපහු 100 වලට root එකක් තියෙනවනේ. ඒක 10. එතකොට 2 එකයි 10 එකයි ඇතුලේ තියෙන්නේ. ඒ දෙන multiply වුණාම 20. හැබැයි 20 එකත් ආපහු කරත හැනේ. ඔව් මේක 4 into 5 කියලා ගත්තේ. එතකොට 2 into 10 20 එක ගන්න පුළුවන් 4 into 5 කියලා. Sorry. 4 into 5. into 5 කියලා ගන්න පුළුවන්. එතකොට මෙතන තව 2 එකක් එළියට එනවනේ. එතකොට 2 into 10 into 2 root 5. That is how much? 40 root 5. ms minus 1. හත මොකක්ද? ඒක මොකක්ද කියන්නේ? ඒක බොට්ස් කියන්නේ j's minus 1 නේ. Right? Make understood? මේකේ ආපහු essay question එකක් තියෙනවා අන්තිමට. Give me the tut. මෙන්න මේ essay question එකක් තියෙනවා අන්තිමට. අන්න ඒක try කරන්න either at home මෙන්න මේක හොඳයි. මේක try කරන්න මෙන්න මේක හොඳ type question එකක්. This one. Page number 9 question 2. හරි. ඒක try කරන්න ඒක කරගන්න පුළුවන් වුණොත් හොඳයි. හරි. ඒක හැබැයි effort එකක් දාන්න වෙනවා. හරි. You have to put an effort. try කරන්න. Got it? Right. Come to the next question. Fifth question. I'll do this. කීයද? First one. First one. Right. So 30 kilogram mass of soil on the surface of the moon needs to be lifted 2 meters to be loaded onto a spacecraft. The minimum work required for this, right? The acceleration due to gravity on the surface of the moon is 1/6 of that on Earth, right? So we can't take the gravitational acceleration as 10. We have to take 1/6 of it, or 10 divided by 6. So the energy, potential energy is equal to mg h. Now we have to take the g as 10 over 6. That's the difference. So mass is 30 kilogram, right? Gravitational acceleration is g over 6 ms minus 2, because it's 1/6 of the Earth, and the height is 2 meters, isn't it? So 6 times 5, 5 into 10, 50, 50 into 2 is 100, right? 100 joules. That was easy. Come to the next one. Now the velocity is given in kilometers per hour. You have to convert it into meters per seconds. Right. So the sixth question, a train traveling at a speed of 36 kilometers per hour was braked due to an accident. Calculate the work done by the friction if the train comes to rest after some time. Now the mass of the train is given 18,000 kilograms, right? So now listen. So what has happened here? You have to find the work done by the friction, or the work done against the friction. How do you calculate it? මොකද? Yes. Right. So what happens here? The kinetic energy the train had is converted into the work done against the friction. නේ. අයි kinetic energy එක එන්නේ මොනවා වෙනවද? velocity එක 0 වෙනවනේ. ඒ කියන්නේ kinetic energy එක waste වෙනවා. The wasting kinetic energy is the energy converted into the work done against the friction. So those two are equal, right? So what do you do? Work done against the friction, work done against the friction equals to half mv square, right? Half mv square. So now before taking the half mv square value, we have to convert the velocity into meters per second. So how do we do it? We have 36 kilometers. Yeah, we have to convert the 36 kilometers into meters. You have to multiply it by 1000, and 1 hour is here in down, like per kilometer per hour, no? So per hour, no, this is the hour. So you have to convert the hour into seconds. 3600. So 36 to 36 cancels out. 2 of the zeros will cancel out. So the 10 is left. 10 is 10 ms minus 2, right? So the value here should be half mass is how much? 18,000, right? 18,000 and 10 square. So that's another 100. So it's 9 and 10 to the power 1, 2, 3, 4, 5. 9 into 10 to the power 5. Isn't it? Yeah, upwards, right? 9 into 10 to the power 5. Now wait. The values are in kilojoules. Yeah. Yes. The values are in kilojoules, so you have to divide this by 1000. So that's 9 into 10 to the power 5 divided by 1000 is 9 into 10 to the power 2. So it's 900 kilojoules. Second answer, isn't it? 900 kilojoules. Got the answer correct?
So 1 liter equals how many kg? 1 liter.
Of water is equal to 1 kg.
1 liter water equals
1 liter water equals 1 kg of a mass, because the density is 1000 kilograms per liter. Right? So come to the next question, question number 7. 1 kilowatt hour is, right? What is 1 kilowatt hour? So 1 kilowatt hour. Now kilo is a prefix, so it's 1000, right? Kilo is a prefix, it's 1000. And watt is what? Watt is work over time, or the energy over time. Huh? Kilo is a prefix, you don't know? Now the watt is work. We discussed. Didn't we? Then we don't have to go through this one. ඒක තියන්න. Yeah. ඒක දැනට තියන්න. Come to this part And before this, I want to come to the page 9. I want you to come to the page 9. Seven, 8, page 9. This one, right? Do this question. Yeah. One by one. කම්මලි කියලා බෑ කරන්න. ඈ? මේකද? ආ. හිතන්න. හරිද? මොකද ඩවුට් එක? Best thing is you think first. නෑ දැන් අද. ඒක අර conservation energy දාන්න එක පුරුදු වෙන එක හොඳයි. දැන් මේ වෙලාවේ අර brainstorm එක තියෙන වෙලාවේ දාලා පුරුදු වෙන්න. තියෙනවා. That's 20 watt. 7. 27 is fine. Do it. Come.
ground line එකේ හැමතිස්සෙම MG 0 කියලා දෙන්න.
කොතනද?
ඒක කිව්වනම් කරන්ට් අග්ගන බේස් එක.
ඉතින් වාට ඕන ඒ ලයින් එක 0 කියලා ගන්න පුළුවන් දිගට.
0 කියලා ගන්න.
පුළුවන්.
ඒක ඕන තැන 0 කියලා ගන්න.
පුළුවන්. නෑ. ඔය එකක් 0 කියලා ගන්න එතකොට හරි. එක ලෙවල් එකක් 0 කියලා අරගෙන හදාගෙන යන්න. ඉතින් ඒක ගන්න පුළුවන්. කිසි අවුලක් නෑ. අයි මං කිව්වේ ඕනම ලෙවල් එකක් ගන්න පුළුවන් කියලා 0. මං කිව්වේ නෑ. Can take any level as 0 as your wish. First question is easy, right? Right. So what is the first question? Calculate the potential energy stored in the object initially. Now it's a 4 meter of height. What is the weight? 2 kilogram, right? So EP equals mg h So mass is 2 kilograms. Gravitational acceleration is 10 ms minus 2 and the height is 4 meters. So the energy, how much? 4 into 2 is 8, 80 joules, isn't it? 80 joules, that's fine. Did you do the second question as well? Calculate the velocity of the object as it passes the point D along the surface. Point D එකේදී මොකක්ද?
half mg square plus mg square.
Yes. Eh? මේකද? D වල velocity කාගේ root 20. Got the same answer. Fine. Root 20 is fine, but නෑ ඒ කියන්නේ root 20 එක decimals වලින් තියන්නේ මොකද SS නේ. SS වල decimal වලින් තියන්නේ. Did you all got the same answer? No. Why? Listen, right? So the second question is asking to find the velocity of the object as it passes the point D. Now they are asking for the velocity here, right? Velocity here when the object moves from here to here, right? Yeah. Now the complete potential energy here of a 4 meter height converts into kinetic energy here, and now the kinetic energy here is going to convert back into the potential energy plus, now the potential energy plus the kinetic energy, right? Because it doesn't move the 4 meters of a height, so it moves the 3 meters of a height. That much of a potential energy is given back, and the rest is kinetic energy. So what will be the equation? The half m square or the 80 joules. Now because the 80 joule, now the 80 joule here is converting back into kinetic energy 80 joule here, right? So I can write it as the kinetic energy at C, Ek at the C point, right? Ek at the C point equals mgh at the D point plus half m square at the D point, isn't it? This is correct, right? The kinetic energy here at the C point is equal to mgh at D plus half m square at D. So now the kinetic energy here is 80 joules, right? And the mass is 2, is 10, h is 3 plus half mass is 2, we only don't know the v square. Have to simplify it and find the v, right? So now what happens here? 2 to 2 cancels out. Now this is 2 into 10 is 20, 20 into 3 is 60. So you take the 60 to this side, becomes minus 60. So v square equals what? 20. Now v is root of 20, ms minus 1. Better you simplify it because it's a SA, right? Did you all do the third question as well? Calculate the velocities of point E and F. Right. Do it. Calculate the velocities at E and F. Shiny is appearing and disappearing. I don't know if you got the lesson properly. So let's try to go through the question. All right, I'll watch the recordings again. Now this, the connection troubles are there always. Now try the Starlink, right? People should try the no for real. Now that's 15,000. No? So like gather with 3 of the families like close by. It's unlimited, no? So one only have to pay 5,000. So it's unlimited. The speed will be little bit slow, but I hope that will be fine because it was 40 Mbps to something more than that. Speed will be 40 Mbps above. So get together with 3 of the families. So only one will have to spend 5,000 per month. It 840 Mbps තියෙනවා. ඒ පොඩ්ඩක් අඩුයි මොනවා 20 තිබ්බයි කියමු.
මම ෂෙයා කරන්න යනකොට ඊට වඩා කොස්ට් එකක් යනවා.
නෑ අපි කියන්නේ නෑ.
නෑ රවුටර් එක තියෙනවා.
ඔව්.
රවුටර් එකේ.
ඔව්.
ප්‍රොසෙස් වලට එවන්නත් එපා.
ඔව්.
තව ඩිවයිසස් ගන්න ඕනේ ඒකට.
නෑ ඉතින් ඒක රේන්ජ් එක මදිද Wi-Fi එක කියන්නේ ගොඩාක් දුර නෑනේ. ඉතින් මේ Wi-Fi මේ Wi-Fi එක අපි ජිම් එකෙත් පාවිච්චි කරනවා.
ඒක මෙච්චර පොඩි
ගැප් එක ටිකක් ළඟයි.
ගෙවල් ගත්තොත්
ටිකක් දුරයි. මදිනේ. එහෙනම් දෙකක් at least 7,500. ඈ?
ෆ්ලැට් එකක් තිබුණා
තුන අමාරුයි. The question or the ගෙවල් තුන? question 3 okay.
ෆ්ලැට් එකක් තිබුණා නෝලක් නෑ.
ඔව් ළඟ. නේ?
කාරිද?
Best solution is ළඟම ගෙවල් තියෙනවා නම් take one. Oh, unlimited. So it's even 7,500 නේ 15,000 නේ තියෙන්නේ. 15,000 thing starting unlimited, can browse for any time. ගෙදර? I'm not sure if there's a device to connect, then yeah. ඒක තමයි සාමාන්‍ය devices ඇති connect වෙන්න පුළුවන් devices ඇති. ඒ කියන්නේ ගෙදර ඉඳන් නැතුව connect වෙන්න. ඒ කියන්නේ ගෙදරට විතරද? නේ?
නෑ නෑ ඩිෂ් එකෙන්.
ඔව්.
ඩිෂ් එකෙන් රවුටර් එකට යනවා.
ඔව්.
රවුටර් එකෙන් ඕනනම් ස්විච් එක කරලා දාලා ලෑන්ඩ් එකක් හදලා එහෙම දාන්න පුළුවන්.
land එක.
ඒ කියන්නේ ස්විච් කියන්නේ
land port එකක්ද?
පෝට්ස් ගොඩක්
land port එක.
ඒකෙන් ඇඳන් යනවා අනිත්
වට එක. නේ කියන්නේ අපි කොහෙද යනකොට පාවිච්චි කරන්න බෑ.
වාහන වල තියන්න.
ඔව් එහෙම අරන් යන්න. ඔව්. නේ ඒක තමයි කියන්නේ ගෙදර තියෙන එක මෙහෙට කනෙක්ට් මේ කනෙක්ට් වෙන්න බෑනේ.
SLT නෙවෙයි.
ඒක තමයි.
SLT
ඈ?
නෑ නෑ SLT හැබැයි මෙහෙම.
SLT එක පාඩ. අනිවාර්යයෙන්. කියන්නේ අනිත් එක ඒගොල්ලන්ගේ අර මේ මොනොපෝලි එක වැඩි. මහා කැත විදියට
අපේ ගෙදර ෆයිබර්
hardware installation cost is expensive. So, it is like 1.5 lakh වගේ යනවා. installation වලට.
ඩිෂ් කියන්නේ පැකේජ් එකට
නෑ installation වලට.
ඩිෂ් එකට
ඔව්.
ඩිෂ් එක මොකද ඉන්ස්ටෝල් කරන්නේ?
ඒ කියන්නේ ඔක receive එකක් එපේ. receive එක install කරන්න
$100 to 200
1.5 lakh වගේ මට මතකයි. ඈ? 8 million පිසුදු බං $100. Oh. Right, come to this one. Calculate the velocities of point E and F. Listen. So now what happens here? Now all the 80 joules are here now with the kinetic and potential energy, right? Now that 80 joules converts into the kinetic energy at E, right? And then the kinetic energy at E converts into the the kinetic and potential energy at F, right? So what can you do? So now the 80 joule is here, and this mgh will be adding to it. Either, now you can put the formula like this. Shall I erase this one? Keep. එකමාරක් වගේ යනවා. €75. Approximately 15,000 වගේ නේ. 26,000? No, 15,000 package එකක් තිබ්බනේ. No, 17,000. Even 70,000 is right. 15,000 something. Now listen. Now 80 joule of energy is here. Listen. 80 joules of energy is here, right? So that energy is converted to the kinetic energy here, and bit of a minus mgh is also added, right? නැත්තම් ඔයාට මෙතන 80 joule වල ඉඳන් 80 joule වල ඉන්නේ මේ height එකත් එක්ක. ඒකට මේ height එක add කරලා තමයි equal කරන්න වෙන්නේ half m square වලට. දැන් මෙහෙම බලන්නකො. මෙතන 80 joule තියෙනවා. ඒ 80 joule එක equal වෙනවා මේ height එකේ energy එකනේ. equal වෙනවා half mv square at the bottom at E plus මේ height එක මොනවා වෙනවද? minus වෙනවනේ. minus mg h, isn't it? මේ තමයි energy at the D point. ඒක equal වෙනවා half m square here, sorry, half m square here plus minus mg h මේ ටික. එතකොට එනවා කොච්චරද බලන්න? 80 joules equal half mass is 2, v තමයි අපිට හොයන්න තියෙන v square එක minus මේක 2 kilogram, g is 10, height is how much? 1 meter, right? So how much do you get here? 20 එක මෙහෙට එනකොට 100 වෙනවා. So v square equals 100, v equals 10, m is minus 1. Got the answer? Up. Right. මොකද උනේ? You're laughing at. Third question. The velocity at E. ඒ half m square එක minus ගන්න. ඒක බෑනේ එතකොට. logically බෑනේ. ඒ කියන්නේ half m square එකට minus එකක් අපි දාන්නේ නැහැ නේ. mgh එකෙන් plus minus දාන්නේ. නේ? නැත්තම් ඔයාලට ලේසිම වැඩේ මොකද්ද? මෙතන height එක 4යිනේ. ඒ 4 height එකේ mgh නේද completely මෙතන kinetic energy වෙන්නේ. එහෙම වෙන්න බෑ. ඒ වෙලා තියෙන මොකක්ද දන්නවද? additional kinetic energy එකක් තියෙනවා මෙතන. ඇයි? මෙතනින් මෙහෙම උඩට එනකොට මෙයා මේ stationary නෑනේ. දැන් ඒ object එක මෙතන ඉඳන් මෙහෙම එනකොට දැන් මෙතන තියෙන 4 meters වල තියෙනවානේ energy එක. ඒක මෙතන තියෙන kinetic energy වෙනවා. ඊට පස්සේ ඒ kinetic energy එක 80 joules නේ ඔක්කොම. ඒ 80 joules වලින් 3 meter height එකේ potential energy එකට කොටසක් ගිහිල්ලා ඊටු කොටසක් kinetic energy එක විදිහට ඉතුරු වෙනවා. ඕනම් බලන්න මේ kinetic energy කොච්චරද කියලා. මේ 3 meters height කියලා කියන්නේ mgh දැම්මොත් කීයක් එනවද? mass එක 2යි, gravitational acceleration එක 10යි, height එක 3යි. mgh කීයද එතකොට? 60යි. එහෙනම් මෙතන kinetic energy කීයද? 20යි. ඒ 20 plus 4 meters වල potential energy එක තමයි completely මෙතන convert වෙන්නේ kinetic energy එකට. correct? එහෙම ගන්නත් පුළුවන්. මෙතන half mv square kinetic energy එක plus 4 meters වල potential energy එක තමයි මෙතන kinetic energy එකට convert වෙන්නේ. get it? Because this is already moving here with a kinetic energy and there's a 4 meter of a height with a potential energy, and this kinetic energy, this potential energy completely converts into the kinetic energy at the bottom. බලන්න එතකොට කොහොමද එන්නේ කියලා. Shall I erase this one? online bro photo අරගෙන හරියන්නේ නැහැ. photo අරගත්තාන් පස්සේ use a paper. Now the bro is lazy. Not telling that. Okay. Right. So what happens here? Now we already found the kinetic energies. 20 joules there. So what I have to write here is half mv square at d, right, plus mgh. Now I am taking the gravity zero level, the potential energy zero level as this one, right. So the half mv square is here. Now the mgh is this height 4. Is equal to the final kinetic energy half mv square at the bottom. Get it? 20 එක නැතුව. මෙතන kinetic energy නැතුව. ඒක ගන්න එපා. අයි මෙතන moving නේ. නතර වෙලා නෙමෙයි. stationary නෙමෙයි moving in. Now if you want you can cancel out all the m's. Now half, do we know the v? I can cancel can't cancel. I didn't cancel it. Right. So half mv square is now here is 20. We already know it. Plus mgh is 2 into 10 into how many meters are there? 4 meters are there. Equals half mass is 2 v square. Right. So how much do you get? This is 20 into 4 is 80, complete one is 100. So v square equals 100, right? So the v equals 10 ms minus 1. Gives the same answer, right? Yeah, give the same answer. Oh, yes. E. You are taking pictures of me? Right, 10 ms minus 1. Now the thing is keeping all the details in the mind, that's the thing. I am missing the part that there's a kinetic energy here or there's a velocity here at the top, don't you? That happens. Like you have to keep it in your brain, keep it in your mind. Now like a good question is that it has more details that you have to keep it in mind, and observing all those you have to apply it with all together. and the confusion occurs. And if Ravishka was here now, he'd be dying. Complete line. Moon nikan. Yes, yes. I can see. He's not online anyways. Somewhere around 1,80,000. Yeah, for the Starlink. එහෙනම් රවිෂ්කින කඩා වැටිලා නාය රතු වෙලා කොළ කොඩ වෙලා
රෙකෝඩින් කරනකොට ඒක
ඒක තමයි මේක පුළුවන් කියලා තමයි ආවේ නැත්තේ. දැන් මේ ගානක් දීලා බලන්න ඕන. ඥාව වෙයිද දන්නේ.
චමට්ට තමයි කෝල් එකේ.
ඔව්. දැන් ඊට පස්සේ කලකිරනවා. මේක අදාපු නැති එකට. අනිවාර්යයෙන්.
ඕකේ දැන් ඕකම ICT එකේ තෝරනවා.
ඔව් මානවින් දන්නේ ඊට පස්සේ. Right, now come to the next calculation. If H is a horizontal surface and GH is a rough surface, the coefficient of the friction of GH. That's a good question. Eh? Oh? Okay. Right. Alright. So what happens here now? The energy or the kinetic energy here. Now this is the gravity, the potential energy is 0 level. So the complete kinetic energy here converts into the velocity or the kinetic energy here and the potential energy here, right? Now the potential energy increases only 2 meters. The rest of the energy is kinetic energy, isn't it? So what can we write here? The kinetic energy, again I have to erase this. Right. So the kinetic energy here, half mv square at E, right, gets equal to the mgh at F, mgh at F plus the half mv square at F, because the potential energy here is less, right? Because only a bit of the potential energy is increased here. The rest of the energy converts then into kinetic energy, right? So I have to equal those two things. So we already know the velocity here, right? That is 10. Yes. So I have to put the half, mass is 2 kilograms, and the velocity is 10. It's square equals mass is 2, gravitational acceleration is 10. H is how much? 1, 2 plus half, mass is 2. Now the Vf we don't know, Vf square we don't know. So simplify it. Now this 100 is here, 2 to 2 cancels out, 2 into 2 is 4, it's 40 here. Now let's write the 40 plus Vf square. Take the 40 to the other side. Vf square equals 60. So Vf equals root of 60. 7.7 1 4. Okay. 60. So it's root of 60. M is minus 1. In value 7.745. M is minus 1. Did I do something wrong? This is there. 7.745 meters per second. Can't write it further. So it's 60 root. M is minus 1. Now the good question comes the last. Bro, it's like a paparazzi, yeah? You have to do it now. The fourth. Eh? Now we are going bit further than 5. Do the last question. Because like තව චුට්ටක් තියෙනවනේ. ආපහු අද මේ එකක් ඩිස්කස් කරලා යනවා චුට්ටක්. මොනවාද efficiency. පවර් එක ඩිස්කස් කරෙත් නේ. යා යා. ඒ ටික ලේසි. right? මේ කරපු එක හොඳයි මොකද නැත්තම් අර මේ conservation of energy කියන එක apply කරගන්න නැත්තම් තේරෙන්නේ නැතුව යනවා. Now you understand how to apply the conservation of energy. Yeah? We are applying conservation of energy. Did you know that? Yeah? Yeah. That's the thing. Application. Yeah. A time එක ගන්න. You have to take that time. Yes. Now the first thing is you try it at home and take time to think about it. Doesn't matter if it is hours or days. You have to think about it. And when you are like getting stuck somewhere, watch the video. Now first, before watching the video, try to do it by yourself and just going through the theory. Now you have the simplification. Application is there. So you think about it, what happened there. And it would be good if you can write a note on what you understood. Right? Write a note on what you understood, what the application you did and what happens there. Like the understanding takes time. That's true. I understand that. I completely understand that because I've been there. I've been like, sometimes I've been working on one question from the morning to evening. I threw the books and papers and everything and I again started it. So that happens. But more you struggle, more you learn, more you develop. That's the truth. Right? So there's no any simple way of doing things. So you have to put your brain into it. Think it, you'll understand. If you don't understand it, go through the video back again, you'll understand something. Still you don't understand anything. Oh, salli ganna. Still you don't understand it, you ask it. So I'll explain back. Paksha. Huh? FH is a horizontal surface. Yeah. Exercise 1 එකේද? ඒ උස ගත්තා අපි. ගත්තා. බලන්න කැල්කියුලේෂන් එකේදී උඩ ටික ඔව් 320 උඩ ටික යට ටික 80 නේ. දෙකම ගත්තා. 4. ඔව්. ඔව්. අපි ඒක හදා ගන්න ඕනේ. ලොකෝට ලියන්න ඕනේ. Right? Question 4 එක ඉවරද? කරා? Hey.
ඒක කළා ඊනල්.
Eh?
ඒක කළා.
What do you mean A? Not the 4. 4.
4A.
Not this 4. This 4. We have to do this one. FH is a horizontal surface and GH is a rough surface. The coefficient of the friction of GH is. You have to find the coefficient of the. Huh?
Sir, 4 එකේ A part එක.
Right. Now only I got the question. Calculate the gravitational force acting on the object. Gravitational force. The friction acting on the object in the GH region. They are asking for the friction. First question. Second, if the object is stationary at the point H. Okay. Calculate the distance GH. Those two questions are good. ඒක ආවද කීයද? 8 newtons, right? So shall we do it? Avadu. Calculate the gravitational force or the friction acting on the object in the GH region. Now this height until it comes to the F. Now the energy here was how much? 100 joules, wasn't it? It was 100 joules. Yes. Energy at E is 100 joules. It's 100 joules. So when it comes to the F, how much has converted? If I forget the kinetic energy, the mgh we have converted how much? 40. So how much left? 60 joules are left. Or now the kinetic energy of Vf is, or the velocity at the Vf is 60 root ms minus 1, right? So the kinetic energy will be half me square, and that will be 60 at the last, right? Because it's 60, isn't it? It's 60, right? No, 50 නෙමෙයි, 60 නෙමෙයි. අපිට එතන මේ making kinetic energy calculate කරන්න වෙනවා. Then now listen, right? එතකොට මේ height එක මෙයා ඇවිල්ලානේ. That energy is not like they can මේ 100 වලින් මේ energy එක දැන් it's been wasted. මේ energy එකෙන් 100 වලින් මෙච්චරක් දුන්නා. ඒ කියන්නේ අතරම දීලා තියෙන්නේ 40 නේ. Now the kinetic energy is here. Kinetic energy here is 60. ඔයාට ඕන 60 එක half m square දාලා ගන්නත් පුළුවන්. Right? දැන් මෙතන 60 half m square දැම්මත් 60 එන්නේ. Understand it? No? Now do you understand the energy here is now 100? We calculated it. It's 100, right? And when it comes to the F, the mgh at F is this one, which is 40. So we have given that 40 to the object. The 100 is wasted and the mgh is gained, right? Now the energy left here is 60, right? 60 joules, which is the kinetic energy. Now the work which is doing is by the kinetic energy, right? Now you can't work with the mgh, because if the mgh to work, it has to go down. Now this mgh has stored, or the 40 has stored. 60 is the part which is doing the work, which is the kinetic energy, right? Kinetic energy එකෙන් තමයි දැන් work කරන්නේ. Potential energy එකෙන් ආපහු work කරනවා ආයි පල්ලෙහා යන්න වෙනවා. බෑනේ. ඒතර එයාගේ 40 store වුණා, දැන් 60 joule තියෙනවා මෙතන. ඒ 60 joule වලින් නේද GH වල work එක කරන්නේ. Isn't it? නේද? නේ? එහෙනම් calculate the gravitational force acting on the object in the GH region. So we have to put yes, mu mg equals to what? Yeah, the mass is given, right? Yeah, so easy. Oh, yes. So to calculate the gravitational force or the friction is Fr equals mu m g, or mu r is mg, right? Mu r is the equation, r equals mg. So what are the values here? 0.4, r is 20. So how much is it? 8. Yeah, the friction is 8 newtons. That's correct. Now the kinetic energy is 60 joules here. And while it's going through the GH, it gets stationary. That means the kinetic energy is completely converted into the work done against the friction. We did this question before, right? Now this is getting stationary at the H point. That is the kinetic energy converted into work done against the friction, right? So the question is asking for is what? The object is stationary at the point H. Calculate the distance GH. So the work done here is work done against friction is equal to half mv square or the kinetic energy, right? So the work done against the friction is friction into the displacement of gh is equal to half mv square, right? Do you understand it? The work done against the friction is the conversion of kinetic energy, ne? Right. So friction we already found as 8 newtons. D is to find half mv square. We can either apply the values or it's how much? කෙලිම 60 ගත්තා නම් හරිනේ. 60 නේද ඉතුරුලා තිබ්බේ? 60 joules. I'm putting 60 here. So what happens? D equals 60 over 8. How much is it? Right, equals 7.5 meters. That's a good question, right? Now the Ravishki is definitely going to regret this, for sure. Now this is the level of question that can come to essay. Yeah, this is a standard level of a question. Meter? I don't know. What are the calling question? තුන කලින් ප්‍රශ්නය පස්සේ එක. ඒක F එක වෙන්නේ. මට නම් හිතෙන්නේ මෙන්න මේක අර thinking part එකේ තියෙන මෙන්න මේකේ කියන්නේ work done against the friction එක kinetic energy වලට equal වෙනවා කියන එක. ඒක හිතන්න චුට්ටක් අමාරු එක පාට. පුළුවන් හිතන්න. But a bit of a difficulty is there. Right? Now go through them again. Right? Go through them again. Rather than watching the video, try it by yourself. You have the simplifications, the answers are there. Go through it so you will understand something and try to improve it. Try to improve what you understand and try to apply it on the other questions as well, because many of the questions are there. And I'll be giving the question bank as well. Even the PPC is there, so go to the PPC as well. I'll give a separate question bank on these questions. Rotational motion 80 වෙන කම තියෙනවනේ. Now come to this. What is this? 8. Yeah, the power. Listen. Now this is the part. This is one important part, right? So what is power? Somebody tell me what is power. We discussed it, did we? Yeah. So the image tells the story. What? The uncle, walking on the stairs for the same height as the boy running, right? But would you think he will run at the same time? No. But the heights are same. That means the energies are same. So he runs slowly, he runs faster, takes less time, right? The same energy, time is less, which means that the time taken to run the same energy of the time taken to consume the same energy is less in him but more in uncle. So that means more power is there with the child than the uncle, right? Yeah. Oh. Uncle the power එක ගන්න වෙන මොන හරි ගහන්න වෙනවා. uh, but the boy originally has it, right? So now there is power. So what is power then? Either work over time or the power or the energy over time is power, which is the measured in J's minus 1, which is watts, right? Right. The rate at which work done is called power. The unit is J is 1 over watt. Units like kilowatts, megawatts are used to measure the large powers, right? So the power equals work over time or the energy over time. The energy or power supplied to a machine is called the power input, and the effective power or the power done by the machine is called the power output. In every machine, there is a loss of energy, as we discussed earlier, in the form of sound and heat due to resistive forces such as friction. Therefore, the output power is less than the power input usually, right? So under that we discuss about the efficiency, right? Under that we discuss about the efficiency, and this one as well we will discuss it. Like try to go through the questions in exercise 1 as well, right? Try to go through the questions in exercise 1 as well, and I'll be giving you the tips for the kinetic and rotational motion the next week, right? Hopefully I'll be giving you the tips, and we'll be finishing this part, and in the middle way I'll be starting the rotational motion, right? So do all the questions, go through the questions. The final part we will discuss that here the next week, and go through all the questions we discussed so far, and go through the PPC as well. I think Shiny don't have the PPC. Shiny, do you have the PPC? The past paper classification one, a purple book. Do you have it? No. Right. Remind me to send it. Put me a message. I will send it to you. I will give it to the people here. Or this one. Right. I'll send this to you. Oh, this is 2. Oh, this is 1. This one. This 2. This will be given later. Eh? ඔයාට හොඳ නෑ ඔය. දෙනවද නෑ? ඔයාටත් දෙන්නම්. ඔයාට හම්බ වෙන්නේ නෑ? දෙන්න. ෂයිනිට පෝස්ට් කරන්න. Right. So that's all for now today. Right. So go through the questions back again. Go through the forced questions back again. Do the orderly tute as well. Did you go through the? Completed? All the answers are found? No? Fine. 20 questions. The PPC is easy or the order is easy? Nothing is easy, okay. Anyways, if you're doing something, that's good, because you have to, keep working. That will improve you. Right then, okay. Adios. Mirihana. Shiny, see you the next week. Mirihana? Anyone? Mirihana? Google Maps, you know? Maybe.